Hello, and here are two mock problems for the natural science physics at Cambridge. I mean the interviews. I adopt these two problems from the 200 puzzling physics problems. So let's start with problem A and problem 21, which I think has uh, the attractive let me emerge with it. So here we have an iceberg of an upright pyramid, and it is regular. We have 10 meters above, we call it h, and it tells us to find the period of small vertical oscillations of the berg. And the density of water is of course 1,000 kilograms per cubic meter. So let's assume that the base area is A and the total height is h. So the total mass would be 1/3 times A times h times rho ice. And also we calculate something about h. Now it is static, and the it floats, so we have h cubed minus small h cubed times rho water equals h cubed times rho ice. Actually, we are lacking some coefficients on both sides, but since the upper smaller one is very similar to the overall iceberg, so we can ignore those coefficients. Now we calculate something like the oscillations functions, something like that. So we assume that it has a small deviation from the balanced position of x. The additional submerged volume, let's assume that now the water has become here. The additional submerged volume would be x times a times small h over capital H squared, because we can see this is as a rectangular thing since x is very small. So the total upthrust would be the volume times rho water times g. So this equals to F, and we know that F divided by m equals to A, so this is the second derivative of x, and it equals to minus omega squared x. So now we have to assume that because this F is actually upwards when x is positive, so here's a minus sign. We will calculate that omega equals to 3 times h squared times rho water times g over rho ice times h cubed. So now you just need to plug in some data and you will find it out. Okay? And here's the solution of problem 21. So there are two identical iron spheres, and one of which lies on a thermally insulating plane, while the other hangs from an insulating thread. So equal amounts of heat are given to the two spheres, which will have the higher temperature. So you might think, so why will they're having different temperatures? I mean, these are all insulating, right? So now is the thing that we need to consider. I have to say, when you cannot figure something like that, and you know that it will become larger when it's gaining heat. So for the left hand side, it will become something like this, and we know that the center of mass has risen its height. And for the right hand side, it will be something like this, and the center of mass would decrease by its height. So I mean, the left hand side, the heat gives some of its energy to the rise of the center of mass. So the left hand side would have less temperature, and the right hand side will have the higher temperature. Okay, so these two problems are not very hard, and I think there's a big probability that it will occur at some of our interviews, especially for problem 21. I think it may be very confusing when you see it at the first glance, but now you have known it. And for all the problems concerning about thermodynamics, you have to consider about so the first one, L equals to L0 times 1 plus alpha delta t. So alpha is the coefficient. Now this is a linear coefficient, and we have the area. The area will also become larger, but the coefficient will become 2 alpha delta t, and v 3 alpha delta t. You just need to times this by a third to the cube, I mean. And because alpha delta t is very less than 1, so this thing approximately equals to this, and 3 alpha would be the volume coefficient. So that's all for the first part, and I will continue uploading videos like that, and I hope you like it. So I'll see you next time.